All right, everybody. So I set up this little model to help us understand seasons. I have 4 globes. One of them's the moon because I don't have 4 Earths. I just have 3. And they're all going in a circle around me. Now, I want you to notice a couple things. All 4 positions, the tilt of the North Pole is all facing this couch right here, is all facing this back wall. And so the moon right here is facing that. But again, yes, is the moon, but we're going to consider it to be the Earth right now. And here's another Earth right here. It's facing to me, or that same back wall. And here's another Earth right here, and it's facing towards that same back wall. If I take a look at where the flash in my phone is hitting here on the Earth, it's hitting just about right here. Just about right here. You can see that little bright spot right there. That's from the flashlight on my phone. Well, this is showing more direct insolation in the southern hemisphere. And what that means is that the southern hemisphere is going to receive more direct sunlight when the Earth is tilted away from the sun, and that will give us our winter, giving the southern hemisphere their summer. Now, this happens in December. In December, we get our winter, and the southern hemisphere gets its summer. But if I advance 3 months, so here's December, January, February, and then we have March right here. If you take a look, the burst of light from my phone is hitting right here, right on the equator. And that's where both the northern and the southern hemisphere are both going to receive an equal amount of insolation. This is spring for us. This happens in March. And now if I advance 3 more months, this is March, April, May, June. Here we are in June with the globe facing me. Notice again, the tilt of the Earth has not changed. They're all facing that back wall that I showed you earlier. And the burst of light from my phone is hitting right here. That is our summer. That happens in June. That's when we have warmer temperatures than the southern hemisphere. That's when we have our summer and they have their winter because they're not receiving as much direct insolation. Then I keep on going, July, August, September, and here's where we are right now, September. And if we take a look, it's hitting right here on the equator again, that bright light. This is our fall, the transition from summer into our winter. Now, just a couple of quick things about this. Here we are in September, and then here we are in December. In December, we get shorter days, so we have less direct insolation coming throughout the entire day. This usually happens on December 21 or 22, 23. You don't need to know the specific days, just know that it happens in December. And the southern hemisphere receives more direct insolation than the northern hemisphere. We call this our winter solstice. And where the sun is hitting right now, or the light from my camera is hitting right now, is right here. This is the Tropic of Capricorn. So the Tropic of Capricorn is where the sun is going to be directly overhead and receiving the most direct insolation. 3 months later, here we are in March. And again, this happens like March 21, 22, 23. It's fine if you just know it happens in March. The most direct insolation is striking right here on the equator. And this we call our equinox. This is our spring equinox or our vernal equinox. 3 months later, we shift back here to June. Here we are in June, again, 21, 22, 23. The day is not important to me. And the most direct insolation is striking right here, and that's the Tropic of Cancer. We call that our summer solstice. This is the longest day of the year in our summer. Happens in June. 3 months later, here we are in September, which is the month that we're in right now. And the most direct insolation is right here above the equator. And again, this happens later in September, September 21, 22, 23. We call this our autumnal equinox, autumn, or fall equinox. So we get our seasons not because of a changing distance between the Earth and the sun. We get our seasons because of the tilt of Earth. And because the tilt of the Earth does not change, it always points to the same place. We get varying amounts of insolation striking different places on Earth, which will affect the temperature. Now that directly relates right back to this demonstration that we saw. We saw that more direct light on this thermometer produced warmer temperatures. And less direct light on this thermometer produced a cooler temperature. And we saw that the steeper the angle, like this thermometer, this was warmer than this thermometer right here. Well, as the angle of insolation is more direct, the temperatures are going to be increased. As the angle of insolation is less direct, the temperatures will be cooler. Let's take a look at the seasons by looking at one of the diagrams that was in your activity. We can see everything that we just saw with the globes and on the light board right here within this diagram as well. Let's go ahead and start with diagram B right here. When we take a look at diagram B, we examine the Earth right here, and the first thing that we'll see is that the North Pole is tilted to the sun. When the North Pole is tilted to the sun like this, that means that the Northern Hemisphere has a greater amount of sunlight striking it at any given time versus the Southern Hemisphere, which only has a small amount of sunlight striking it. We could also see that the Northern Hemisphere also receives more direct insolation than the Southern Hemisphere. The position of the Earth right here, with its tilt towards the sun, its longer days and more direct insolation in the north, this defines our summer. And if this were on June 21st, the most direct insolation would be striking the Tropic of Cancer, about 23.5 degrees above the equator, and we would call that our summer solstice. Now, if we jump to the other side of the diagram and we look at position D, that's going to be our winter, and everything there is opposite that we just talked about. The Southern Hemisphere is receiving more direct insolation than the Northern Hemisphere. The Southern Hemisphere will have longer days and shorter nights. This results in colder days in the north and warmer days in the south. This is our winter, but the summer for the Southern Hemisphere. And on December 21st, when the sun is striking directly on the Tropic of Capricorn, we'll call that day our winter solstice. Now, if we jump over here and take a look at diagrams A and C, those are our fall and those are our spring. The fall position is right here at letter C. That's right in between the summer and the winter. And our spring is right here, and that's at position A. That's between the winter going into summer. And that's where the sun's most direct insolation will be striking the equator, and that happens on an equinox. For the fall, that happens in September, and for the spring, that happens in March. And on those days, on both equinox days, whether it be the fall one or the spring one, you'll get equal days and equal nights. You also have to take a look at these diagrams. They also highlight the seasons as well. If we take a look in this diagram, we get a little clue that we have the longest day. But the sun is also highest in the sky. And here we have the shortest day right here, and the sun is really low in the sky. So that means that this one right here is going to be our summer. And this one right here is our winter. And here we have that day and night are equal, so that'll either be our spring or our fall. Now you can also get one more hint here. If you take a look at the shadows that are in each diagram, here in the summer the shadow is really small because the sunlight is most direct. And here the shadow gets really long because the sunlight is less direct, so it produces that long shadow when the sun is lower in the sky. And here that shadow is right here in the middle because it's showing that that sun is somewhere between the longest day and the shortest day. I hope this video has helped you understand the seasons a little bit more. If you have any questions, please don't hesitate to ask in class.